Okay, so question 3 is all about correlation coefficient, so it's going to ask us to use our calculator to work out the value of correlation coefficient. On your calculator, if you do menu and choose option 6 to take you onto your statistics menu, you're looking at two variable statistics. You're looking at a linear regression model, so option 2 gives you linear regression, so with two variables. You then need to just enter your data, which I'd like you to do now. Test 1 can go as X, test 2 can go as Y. Now that your data is entered, if you press Option, and you are looking at a regression calculation, because what we're doing is using a linear regression model, so it's going to be option 4. And in there it should give you the regression equation and your value of the correlation coefficient. So to three significant figures, your value of correlation coefficient is going to be 0.789. So let's make a note of that. Okay, so for part B, it's asking us to do a change in either of the test marks to a percentage. Now remember, the correlation coefficient shows how good the line of best, how close the points are to the line of best fit. If I change the unit of measurement, that's not going to change anything about the degree of the fit, so it will remain unchanged. Part C asks us to conduct a hypothesis test on whether or not there's positive correlation. So we're going to just start by looking at our critical values. So I've got 1, 2, 3, 4, 5, 6, 7, 8. I've got n equals 8, and I've got my level is going to be 0.01, significance level is 0.01, and it is a positive correlation, so I don't need to halve my significance level, which I would do if it was a two-tailed test. We know it's a one-tailed test. So let's have a look at our critical values for n equals 8 and 0.01. So here's my table of critical values. I've got n equals 8. I'm looking at 0.01. It gives me a critical value of 0.7887. Okay, so we're going to set this up formally. We're going to say that the null hypothesis, which is always how we set this up, the null hypothesis is going to be that the real value of the correlation coefficient, which we use as rho, equals 0, and the alternative hypothesis is that the real value of the correlation coefficient, because it's positive correlation, must be greater than 0. We know that the sample correlation coefficient we worked out equals 0.789, and our critical equals 0.7887. Now I'm just going to go back to the value we had on our calculator, because these are so close to each other that to three significant figures they are identical. So if we look back on our calculator, I'm going to just take this to an additional significant figure. It gives me r equals 0.7889. Okay, so these are almost identical, that they're only out by a difference of 2/10,000ths. Okay, so let's have a look. Do we choose to reject or not reject our null hypothesis? So here we've got our value is going to be centered around 0. Our critical value is 0.7887. That's our critical. Anything to the right would tell me to reject H0. 0.7889 is to the right, so 0.7889 is greater than 0.7887, implies reject H0, implies. Now we always make sure that we give a worded solution to this. There is sufficient evidence to suggest positive correlation. positive correlation between the two tests. Okay, we're going to go on to part D. So for this we need to go back to our calculator screen, which tells us what the regression model was, and it tells us that y equals a plus bx, and it gives us a value for a as 3.96, so y equals 3.96 plus 0.462x. So let's just make sure we've got that written down. Remember in how we entered this, in test 1 we entered for y, in test 1 we entered for x, test 2 was y. So we can say that our test 2 score equals 3.96 plus 0.462 times test 1. Okay. Student was absent from the second test, but he obtained 30 marks in the first test, so we can just substitute in his 30 marks in the first test to say equals 3.96 plus 0.462 times 30. Well, let's just substitute those in on our calculator. We're going to have 3.96 plus 0.462 times 30 equals 17.82. So we're going to estimate as 18 marks, because that's a reasonable degree of accuracy.